Hello, this is the lecture number 3 for the chapter Straight Lines for the class 11th, and we were discussing the exercise 10.1 and we have done up to question number 3 in the last lecture. Now in question number 4, it is given that you have to find the point on the x-axis which is equidistant from the two given points. So any point on the x-axis, let us call it x0, because any point on the x-axis its y coordinate will be equal to 0, and it is given that it is equidistant from the points, from the point A. First point is 7, 6, and the point B, which is 3, 6. Now what is given? It is given that PA is equal to PB, that this point P is equidistant from the two given points A and B. So use the distance formula. PA will be under root x minus 7 ka whole square plus 0 minus 6 ka whole square is equal to PB x minus 3 ka whole square plus 0 minus 4 ka whole square. When you squaring both the side, the square root will be cancelled out, and you'll get a equation as a square plus b square minus 2ab plus square of minus 6 is 36, a square plus b square minus 2ab plus square of minus 4 is 16. So x square will be cancelled out with this x square, and it comes out to be 8x is equal to minus 60, which gives x is equal to 15 upon 2. Therefore, the point P, which is 15 upon 2, 0, lie on x-axis. So this is the type of question you have already done in your class 10th also. So you have to find the point on x-axis, and any point on the x-axis coordinate is x0, and it is equidistant from the two given points A and B. Now in question number 5, you have to find the slope of the line. In question number 5, you have to find the slope of the line which is passing through the origin. You have to find the slope of the line which is passing through the origin, that is 0, 0, and the midpoint of the line segment PQ. Midpoint of the line segment PQ, whose coordinates are 8, 0, and the coordinate of P is 0 minus 4. I have made this a rough figure. 0 minus 4 will lie on the negative y-axis. So I have taken only the rough figure. So it is passing through the point, you have to find the slope of the line which is passing through the origin, whose coordinate is 0, and the midpoint of PQ. So the coordinate of B will be the midpoint of PQ, x1 plus x2 upon 2, y1 plus y2 upon 2 will be the coordinates of the point B, which is coming out to be 4 minus 2, which is coming out to be 4 minus 2. This is the coordinate of the point B. Now you have to find the slope of AB, slope of AB. Now the slope of AB will be y2 minus y1 upon x2 minus x1, which is coming out to be 2 upon 4, that is 1 upon 2. So this is the slope of the line which is passing through the midpoint of the line segment PQ, whose coordinates are given as 0 minus 4 and 8, 0. First of all, I find out the midpoint of PQ, which is B, as 4 minus 2, and the slope of the line which is passing to the origin and B will be y2 minus y1 upon x2 minus x1. So y2 minus y1 is equal to x2 minus x1. So the slope of the line, you find it again, AB, whose coordinates is AK coordinate has 0, 0, and the coordinate of B is 4 minus 2. So it will be x2 minus x1 upon y2 minus y1 upon x2 minus x1, which is coming out to be minus 2 upon 4, that is minus 1 upon 2. is the slope of the line AB. So this is the question number 5. Now in question number 6, read it carefully. What is given in the question number 6? It is given that without using the Pythagoras theorem, you have to show that these are the vertices of the right angle triangle. So I have taken these 3 points as 3, 5 and third as -1, -1. Now you have to show that these are the vertices of the right angle triangle. So what I have to do, because I don't have to use the Pythagoras theorem, so I will use the concept of the slope. So I will find the slope of AB, which is coming out to be y2 minus y1 upon x2 minus x1, which is coming out to be -1. Then the slope of BC will be y2 minus y1 upon x2 minus x1, which is coming out to be 3 upon 2, and the slope of AC will be y2 minus y1 upon x2 minus x1, which is coming out to be 1. Now because the product of these two slopes is coming out to be -1, because slope of AB multiplied by the slope of AC is coming out to be -1 into 1, that is -1. Therefore AB is perpendicular to BC. It means that is the triangle is right angle at A. This is a triangle which is right angle at A. Therefore angle A is equal to 90 degree. So therefore it is a right angle triangle. It is a right angle triangle. You find the slope of all the 3 sides of the triangle, AB, AC and BC, and from this it's being observed that the slope of AB into the slope of AC is coming out to be -1. So therefore AB is perpendicular to AC. Therefore the triangle is right angle at A. You can easily tell in a right angle triangle which is the angle is right angle. Now in question number 7, find the slope of the line which is making an angle of 30 degree with the positive direction of the y-axis. Now you have to find the slope of the line which is making an angle of 30 degree with the positive direction of the y-axis. So be very careful. So I have drawn this figure, and you have to find the slope of the line L. Now because this angle is equal to 30 degree and this angle will also be equal to 30 degree because they are vertically opposite angles, and this angle you have to find, because you have to find the slope of the line, we have to find the angle of inclination, that is the angle made by the line with the positive direction of the y-axis. I draw the figure once again like this. This is the 30 degree angle. So this is the anti-clockwise and this angle is equal to 30 degree. Now this angle is 90 degree. So angle of inclination made by the line L, that is theta, will coming out to be exterior angle equal to sum of interior opposite angles. So it will be equal to 120 degrees. So the slope will be equal to 120 degree, that is tan theta. So you find the slope, that is tan 180 is equal to tan 120 is equal to 180 minus 60. So it is coming out to be minus tan 60, that is minus √3 will be the slope of the line which is making an angle of 30 degree with the positive direction of the y-axis. So like that you can draw the figure. Now in question number 8, what you have to do? In question number 8, find the value of x so that these 3 points are collinear. You have to find the value of x which is given that these 3 points are collinear. Now because these 3 points are collinear, you can use the concept of the area of the triangle, but you can also use the concept of the slope. Therefore the slope of AB will be equal to slope of BC when the points are collinear. So you can easily put the slope of AB is equal to slope of BC, and you will get the value of x. You can use the concept of area of the triangle also. The slope of AB will be y2 minus y1 upon x2 minus x1 is equal to slope of BC, y2 minus y1 upon x2 minus x1. When you solve it, you will get the value of x as 1. Cross multiplying it, you will get the value of x as 1. So this is the question number 8. So easy method to, when the points are collinear, you can use the concept of the slope. Now in question number 10, find the angle between the x-axis to the line joining these 2 points. That is, the points given as 4 minus 2, and the another point is 3 minus 1. You have to find the angle made by this line with the x-axis. So if I find the slope of this line by using both the method, that is the slope of the line passing through the 2 points and the angle made by the line with the positive direction by the y-axis. So x-axis, sorry, the slope of AB will be equal to y2 minus y1 upon x2 minus x1, which is coming out to be minus 1, and the slope of the line is also tan theta, which is equal to minus 1. Now you can easily find the angle made by the line with the positive direction of the y-axis. So for minus 1 you can write minus pi by 4, and for minus tan theta you can write 180 minus theta, which is coming out to be 3 pi by 4. So tan theta is equal to 3 pi by 4, which gives theta is equal to 3 pi by 4. So this is the angle made by this line with the positive direction of the y-axis when it is passing through the 2 points. What I have done, I find out the slope of AB passing through the 2 points and put it equal to tan theta, which gives the angle made by the line with the positive direction of the y-axis. So this is the question number 10. Now in question number 11, which says that the slope of the line is double the slope of the another line, and if the tangent of the angle between them is 1 upon 3, you have to find the slope of the lines. So let the slope of one of the line L1 be m, therefore the slope of the another line width will be 2m, and let us call it m1, and let the slope of the line be call it m2. And by using the formula to find the the angle between the two lines, you can easily find the angle between the slope of the lines. Now we know that the angle between the two lines is m2 minus m1 upon 1 plus m1 into m2. The tan theta is given as equal to 1 upon 3. 2m is the slope of the second line, m is the slope of the first line, 2m into m. Now you have to solve this equation to find the value of this m. So it will be equal to, when you solve it, it will be equal to 1 upon 3 is equal to mod m upon 1 plus 2 mod 1 plus m square. And when you solve it, when you remove the modulus from 1, you will get the positive negative sign in the left hand side. When you solve this quadratic equation, you will get the value of m as 1 and 1 upon 2. That is, the slope of one of the line is 1 and half. 1 and half. And correspond to this, you will get the value of plus minus 1 and plus minus half. So therefore, if the slope of the one of the line is 1 minus 1, half minus half is the slope of one of the line, and therefore the slope of the second line, when the slope of the one line is 1, then the slope of another line will be 2. If the slope of the one of the line is minus 1, then the slope of the another line will be minus 2. If the slope of the one of the line is half, then